Hello everyone. Now today we are going to see the equivalent linkage and its application. So previously in the previous lectures we have studied that what do you mean by link? Link is nothing but a rigid element which is used to transmit the motion as well as forces. So as per that definition, so links can be used in a machine as well as the links can be used in the structure. In machines, there will be combination of links so that by giving some input, you will be getting some output. And for the structure, for example, stresses, in that case, only forces or load can be transmitted. So that part of links now we are going to see how that links we are now converted into equivalent part. So for that purpose, what do you mean by equivalent linkage? So many times the physical shape of connection between the links is such that the actual nature and function of the connection are not get noticed. And this is mainly on account that the center of relative pair is not directly apparent. Means what? For example, whatever the links we are using, they are not directly giving the exact motion. For example, for the four bar chain mechanism, we can say that the rotary motion of crank will be get converted into oscillating motion of the rocker. But for some of the cases, means that motion, how it is possible by the help of Grashoff's law, we are saying that for the four bar chain mechanism, rotary motion of crank will be get converted to oscillating motion. But in some of the mechanisms, we are not able to predict that whether the motion will be circular or oscillatory. So in that case, we have to use these equivalent linkages. So in these equivalent linkages, very often the mechanism with higher pair can be replaced by the lower pair. So as we know the definition, what do you mean by higher pair? Higher pair is nothing but the pair in which the two both of the links will be having point contact or line contact. And for the lower pair, the contact between the two links may be surface or area contact. So in that case, if it is having a higher pair, then we can replace it by lower pair. And if there is lower pair, we can replace it by higher pair. It is a vice versa condition. And this equivalence is valid for studying only the instantaneous character. It means for instant only, if we can change this configuration. And the equivalent lower pair mechanism facilitate analysis as a certain amount of sliding takes place between the connecting links in a higher or lower pair. Means, for example, if you are taking a sliding pair, that sliding pair may be replaced by a rolling pair or maybe by some sliding to sliding also. This is not necessary that we can just convert higher to lower. It may be higher to higher or it may be lower to lower, depending upon the requirement. So now we will see the cases of these equivalent linkages. So now the first case is what? If you see here, turning pair in place of sliding pair. Means what? Here, the sliding pair, kinematic pair, it has been replaced by the turning pair. Now in this diagram, in this configuration, this mechanism is given in which this crank one is fixed, means sorry, the link one is fixed, then the link number two is the crank, which will be having rotary motion, then the link three is the coupler which is attached to the slider. And this slider, it is sliding in the slotted circular slot, which is having some specific radius R. So here, the rotary motion of crank will now lead to oscillating motion of this link number three. And this link number three motion is given to link number four, that is the slider, which will be having sliding motion inside this curved slot. So rotary motion will be converted into oscillating motion. Now the same configuration sliding pair, now we are going to replace it by turning pair. If you see here, one is same fixed link, second is the crank, which is having rotary motion, third is the coupler. Now here, instead of sliding pair, slider here we have inserted one link number four, whose length will be equal to this radius. And so the rotary motion of this crank will be lead to the oscillating or rocking motion of the output link. So here rotary motion will be converted into oscillating motion. And one basic difference is what? This slider is been replaced by the link number four, and here one turning pair is introduced. Means here sliding pair means here are two pairs. This is one turning pair and this is sliding pair. Now this sliding pair is replaced by only turning pair. So here we can say the example of equivalent linkage is what? Turning pair has been introduced in place of sliding pair. The next is what? Turning pair in place of higher pair. So we know what is the definition of higher pair. Higher pair is nothing but the pair in which the two of the links will be having point or line contact. So suppose now if you see here, this link number one is fixed, link number two is a one lobe. link number 3 is another lobe, and this one is fixed. Okay. So these two lobes will be having a point contact here. Now this point contact is now replaced by the turning pair here by addition of this one link. If you see here, there are three links: 1, 2, this lobe, and 3 is this another lobe. This is already given one number. Now here, if you go either of the motion, then they will be having only oscillating motion here. There will be no any rotary motion. So this is one higher pair. Now here, if you see, one additional link is added, and here turning pair is introduced at this point B and at this point C. So this both of the links will be having as this intermediate link. So both of this link 2 and 3 will be having oscillating motion. There will be no any rotary motion. So here the higher pair, which is shown here, will be now replaced by turning pair. Means by adding one additional link to this part, here two turning pair are introduced, so that the higher pair is replaced by the lower pair. As I have told you in the previous first slide, that equivalent linkage is nothing but what? By introducing the higher pair in terms of lower pair, or by introducing lower pair in place of higher pair. It is vice versa condition. So in this case now, higher pair is replaced by lower pair. Here there are two turning pair at point 2, at point this B, one turning pair, and at point C another turning pair. So these are the lower pair. So higher pair is it is been replaced by lower pair. So this is turning place in place of higher pair. Now next is what? Turning pair in place of higher pair. Same example here. Now it is a cam and follower system. So this cam is this link number 3 will be having rotary motion. This is the follower which will have oscillating motion, and this higher pair is replaced by addition one link. So that the B point will be having turning pair, and C point will be having another turning pair. We have introduced one another additional link, link number 4. So this is the another example of turning pair in place of higher pair. Next place is what? Next is given what? Now for this case, now turning pair in place of spring. So if you now see here, this is link number 1, this is link number 2, and this link 1 and 2 is been attached by this link number 4 as well as by link number 3. So now this spring is nothing but it is having some elasticity. So if you try to move link number 1 and 2 away from each other, then the spring will try to stretch. But when you release the force, then again these two link number 1 and 2 will again come to its original position. So now in this case, now spring is been replaced by the turning pair. Now if you see here, there will be another additional link, suppose 4 and 5. So spring is been replaced by two binary links, link number 4 and link number 5, and by introducing one turning pair. So here we can say now spring is been replaced by what? 2 means one turning pair. Thank you.